Okay, in this video I'm going to be talking about one-dimensional unconstrained optimization. In a previous video I kind of introduced the idea of optimization and as far as using optimization in engineering, what motivates it, and I talked about the types of optimization that we were going to study. 1D unconstrained optimization was one of them, and there was multidimensional optimization and constrained multidimensional optimization. So we're starting off with kind of the easiest case, which is the one-dimensional unconstrained optimization. Just to kind of remind you, if you watched the previous video or if it's been some time since then, kind of the objective of this one-dimensional unconstrained optimization is to find a max or min of a single function without constraints. Okay. Without constraints. So it's a function of one variable. So f of x maybe has some local optima, maybe a max, a local min, another local max, and we want to be able to find these extreme points. Okay, extreme points. Now, for some functions this is easy. We just simply take the derivative of the function and set it equal to 0 and solve. That's the way that we do it in calculus. But sometimes our functions are more difficult, more complex. There's no way for us to isolate the derivative. So maybe what if our function, if the derivative of our function, let's just say, was equal to x minus e to the minus x. If we set that equal to 0, there's no way that we can actually find the solution to that without using a numerical technique. Now, the fact that I wrote this down should ring a bell, because this is a root finding problem. So the fact is one way to find maxes and mins of a single function, of a single variable without constraints, is to turn it into a root finding problem. So we can use root finding techniques, numerical techniques, such as all the open methods and bracketing methods that we studied, such as, so we'll talk about open methods first. So Newton-Raphson, and the secant method. If we're to use Newton-Raphson, we got to remember now we're talking about finding a root of the derivative. So the Newton-Raphson step, xi plus 1 equals xi. Now our function is the derivative, so we've got f prime at xi on top divided by f double prime at xi. And we can apply this method the same way that we would to get the Newton-Raphson method. Now, if we know the functional form, if we know what f prime of x, if we have some equation for that, then we can use the secant method and do xi plus 1 equals xi minus f prime at xi, and then we use the we use the first backward finite difference approximation for the second derivative. Well, we're using it for the first derivative, so we're taking the derivative of the derivative here. So f prime at xi times xi plus 1 minus xi, all divided by f prime at xi minus f prime at, oops, sorry, this is supposed to be xi. Hold on here, let me get the eraser here. So this is actually supposed to be xi minus 1, xi, f prime at xi minus f prime at xi minus 1. There we go. So this is the Newton-Raphson approach to finding the roots of the derivative, and this is the secant approach. We could also use bisection. So let's see here. We could also use bisection. But remember, all of these, or false position method, where instead of passing it f prime, we're passing, instead of passing it f, we're passing it f prime. So we pass f prime of x instead of f of x. Alright, so besides those methods, using these root finding methods relies on us knowing the derivative. So what if we don't know the derivative? So what if we don't know an equation for f prime of x? Well, there's a method that I'm going to introduce to you. It's a bracketing method called the golden section search method. So the golden section search method. Okay, so this is a bracketing method. Bracketing method. And you only need to know the function, you don't need to know its derivative. So only needs f of x, doesn't need f prime. So I'm going to introduce that algorithm to you guys in another video. Well, maybe I'll introduce just the general concept to you in this video. Maybe not. Yeah, I think I'll do it in a different video. Anyways, let me, there's one other method that I'm going to talk about. So in addition to this, there's another method called the parabolic what is it? I think it's parabolic interpolation. That's what it's called. So parabolic interpolation. Now I'm not going to really discuss this this method, but just so you're aware of it, not going to discuss this method. If you want to learn about it, it's in the book, and I believe there's some slides in my slides on it. Alright, so in the next video I'm going to talk about the golden section search algorithm. I'm going to explain it and probably demo it by hand and help you kind of get a good fundamental understanding of the algorithm so that you could code it up yourself in MATLAB. Alright, so we'll see you in the next video.